So today we will continue the Terraform lab. So yesterday we installed Terraform and um, automate TEC to deployment, right? Hope everyone know the concept. My screen is visible, right?
Yes.
So yesterday we uh, deploy one EC2 machine. So today we will deploy entire data center. Like first one we will create VPC. We already created a VPC manually, right? So today we will automate the deployment, the entire process. Creation of VPC, VPC object creation. Then after that we will deploy. Launch one EC2 machine inside our required VPC. Then we will deploy one application. So first one is VPC. Second, internal gateway, right? Third one, the next component inside VPC is subnet. Fourth one, route table. Next one is route table association, right? Or subnet association. Then next one is after configuring subnet association, what will you do? Routing, right? Routing in the sense of go to the route table and we add one route, right? To make the subnet public or private. Seventh one. EC2 creation. Eighth one will be security group there. Okay, these are the tasks today we will cover using Terraform. You don't have any doubt? All are good, right?
Yeah, basically it's a way to automatically create your cluster in the cloud, right? Give all the specs of your cluster and Terraform will do it for you.
Right.
Is it the meaning of Terraform like forming Earth or forming a basis, something like that?
Sorry.
Yeah, Terra means land and form means to form something. So it's like, does it the name of the
Yes.
software have any meaning? Like it's
Some
creating the
inner meaning,
landscape
some
for
inner
you?
meaning there. Yes. I mean, to like configuring the infrastructure, right? There
Yeah.
we set up the infrastructure. So there is a inner meaning there. So yes, okay. So we have one AWS account, right? So there we will, I mean, fulfill these tasks, and we have a local machine, and we keep enter code in our local machine, then pushing the code to cloud provider. In this case, this is AWS. Local machine. So we need to install the Terraform, then we need to install AWS CLI. Then we need to authenticate with our AWS account using a admin user with the user credentials like a secret key and access key. After that, we install Terraform. Then we initialize the Terraform with the Terraform commands. All the things we cover today, right? All of you. So today we will deep dive into codes. Okay. For example, coming to these tasks. Okay. Uh, so creating a VPC. This is one task in Terraform that we called as like a module. Okay. So coming to each one, like each step here, there is 10 step there. Okay. So we need to create 10 each steps code. Okay. So first we need to, in Terraform, it's called as blocks. So what is a block? Block is a uh, block contains a configuration of specific resources. For example, here we just take one resources that is called VPC. So we need to create a block for the resources VPC in our uh, configuration. Okay. So similar way, we need to create different blocks for each application. I mean each services. Creation of VPC, creation of inner gateway, creation of subnet, route table, subnet, each services. How we manually create each services, you just think about that. Okay. In our previous class, we configure different services, clicking subnet, then giving some details, then configure. I mean, all the things you remember, right? So similar way, we need to create as code. Okay. What are the things we manually do? We need to create whole thing as code. So each codes or each services under each blocks. Okay. So give me a second. I will break down each code. Okay. Before that, I need to configure. Explain is useful, right? Visual Studio Code.
Yes.
Yes.
Okay. So first I'm going to create VPC. So I need to create a block for VPC, right? So inside block, there are some attributes, values, all the things are there. Okay. For example, now we are going to create a block. That block is a resource block, Terraform resource block. We call it as Terraform resource block. So inside the Terraform inside block configuration, we need to provide the resource name and resource type and resource name. Okay. So in our case, this we are going to create a Terraform resource block. So after that, we need to specify which resource that we need to create. In our case, it's VPC. So we need to provide the type as VPC and name as our desired name. Okay. Then we need to provide the what are things that we are going to create VPC manually. I mean, giving the IP, then given name, all the things we done, right? So all the things we need to provide under the resource block. So similar way, this is one of the word snippet. Okay, you can see resource. This is a resource block, Terraform resource block. Then resource type, AWS VPC. This type is actually pre-built. Okay, because we are working with AWS, so this is pre-built one, and this is desired one. We can the name is desired one. We can choose any name. Okay. Then we need to open a curly bracket. Then under the curly bracket, we need to provide the CIDR block. That means the IP for the VPC. So here we provide like 10 series and the net mask is 16. Then under a tag, okay, by manually when we creating this Terraform, we are skipping the tag section, right? So here just adding the tag and name it as production VPC. This is done for creating a VPC in AWS via Terraform. Similar way, we need to create different blocks for our 10 services. That is, for example, then we are going to create what inter gateway. So we need to mention another resources as inter gateway as another resources under the this resource block. Got it? Or any doubt? All of you?
Yeah, looks okay.
What about others?
Yeah.
Mahesh.
Got it.
Okay,
I'm getting.
fine. Okay. So the resource block is for the VPC is done. Now we are going to add another resource, and that is for the internal gateway. So what are the things we need to mention when creating internal gateway? Anyone can tell? Manually.
Sorry, can I ask the question again, please?
When we creating internal gateway in AWS, what are the things? I mean, what are the steps that we need to follow? All I forgot, right? More
Yeah. So when we make the gateway,
internal gateway.
we have to specify its address and then what machines it's connected to, which are closed to the outside world and which machines are open to the outside world, right?
No. I mean just creation of internal gateway in AWS VPC. It's nothing, right? Just to create. I mean, go to the
Just
service.
say resource AWS gateway, AWS underscore IG equal to demo IG. Then it will have a IP address, some value, and it will have some tag.
No, I mean manual way.
Manual way.
Yes.
You go and click stuff to the drop downs.
Right. So it's nothing, just clicking. When we creating internet gateway in dashboard, okay, just click on the service, that internet gateway, then give it a name, right? Then we can directly create the internet gateway. After that, we need to attach to the VPC that we need. Got it?
Yes.
So that's a task. So we need to create similar block for AWS internet gateway. So this is the block. So again, we are going to create a resource. Then the name. Sorry, the type. The type is pre-built, okay? Because this is the one when we are using Terraform, we specify this is the internet gateway. So the Terraform know this is going to create an internet gateway. Then we need to provide the name, type, the source, after the source, the type and the name, okay? Then open the curly bracket. Then we need to attach to a VPC, right? So again, this is VPC ID. This one is a kind of attribute. VPC underscore ID is an attribute. And we need to mention the value. This is the value. So here, what is the value? We pointing to the, the VPC that already created, okay? So our VPC, how we specify the value like AWS VPC. This is our type. So we need to provide the type, then dot, then the name. Okay, name of the resources. So dot name, demo.vpc. Then we need to mention dot ID. So this way we provide the value for the VPC ID attribute. Got it. So next time, for example, we need to identify this is a VPC. So what we'll do, just using the value and ID there, for example, creating a subnet. So we need to mention the VPC ID, right? So again, we need to provide like VPC ID is equal to AWS VPC dot demo dot VPC dot ID. So it's now that this is pointing to our VPC. Got it. Similar way, we can use attribute and values for interconnect with the different services. Any doubt? All clear, right?
Is that the only attribute that you need for the defining the gateway, just which VPC it connects to? With the ID of the VPC? That's the only thing you need.
So this resources is going to create that resource type, that is in the gateway. And it gives a name GW. Okay. This name you can change as per our requirement. Then after creation of the inner gateway, we need to attach to that inner gateway to any specific VPC, right? So in our case, we need to attach this VPC, I mean the created VPC above. So that we need to specify like attribute values, attribute and the value. In our case, our attribute is VPC ID. We need to mention the VPC. And this attribute ensure that this gateway is attached to the VPC identified by AWS underscore VPC dot demo underscore VPC dot ID. Got it? Clear?
Yes.
Any doubt? Anyone?
No doubt for me.
So the next thing is we need to create a route table.
Route table configuration.
So, creation of root table, we know how to create a root table manual way, right? So similar way, we need to create a
creating a root table by clicking the create a root table, and it's connecting to the pointing to the IGW. Sorry,
right.
Internet Gateway.
Yes.
In the same way how we created Internet Gateway, so we have to creation of routing table configuration. So instead of VPC ID, we have to put IGW, I guess.
So yes, similar way we need to create a block for root table. So this is the root table configuration. So here you can see resource AWS root table. So Terraform now this is service called AWS root table, and we need to provide the name root table. And we need to specify the VPC when creating root table. So we need to point, again, we add the attribute VPC ID is equal to the value, the name of the VPC. So this is a name, right? AWS VPC dot demo VPC dot ID. This is the attribute. So this root table is under the VPC. Then we need to add the root, right? So for example, this root for creating, okay, making a subnet public. So you can see the root. Here we had one root, then open the curly, then the CADR block. So CADR block means incoming, the people, okay. This is the internet IP. So 000/0 is internet IP. So this is the destination actually, target. In coming to root table, right? When adding the roots, we just open the root table, then add the target and the destination. So first one is the target, and the next one is the destination. So coming to destination, we again use attribute. That attribute is gateway ID. Then we need to specify the internet gateway name as value. That is internet gateway .gw. So we have the similar internet gateway here. You can see internet gateway .gw. So coming to here, internet gateway .gw.id. So this would be the value for the internet gateway. So this routes now there is an internet gateway already we created in the same VPC, and it's pointing to that internet gateway. And we add a tag for the root table, that is production root table. Anyone have any doubt? Clear?
Yes.
Now we are going to create a subnet, okay? Now we only created, not only like created a VPC inner gateway, then it's connected with the attributes and values, then create a root table, then that root table is associated with the internal gateway and VPC. Now we are going to create a subnet. So what are the things that in our mind when we creating internal gateway, subnet? We need to provide the subnet name, right? We need to choose a VPC.
Yes.
We need to provide the subnet IP and the availability zone, right? When we creating subnet, we need to choose the availability zone. These are the manual way. So we need to mention all the things in the block of subnet. So this is the block. Again, we start with the resource, and resource type is set by subnet, then the name, my subnet, then VPC ID. Again, attribute VPC ID is equal to our VPC name. AWS VPC demo ID, same VPC we need to mention here. And CDA block, we need to mention the IP 10.series. So here we use the 10.series. So here also we need to use the same IP series 10.1.0.24. Then the availability zone USC is to 19. We need to ensure that these availability zones are available in our corresponding region. Otherwise, we will, our execution will fail. Then tag. Under the tag, we need to mention the name production subnet. Got it? Clear? All of you?
I have one question.
Yes.
So in the CIDR block, the number after the slash is bigger. That means you have less spaces, right? Because it has masked that many digits.
Yes.
So the 24 is bigger than the 16. That's why it can be a subnet of this VPC. Otherwise, it wouldn't be able to be the subnet, right? Subnet has to be smaller than the
VPC
network that it's part of.
For example, this VPC have 100 mangoes consider, okay? So how we share divide the mangoes to each subnet. Only we can, for example, we need to create 2 subnets. So 50 goes to first subnet and the leftover 50 goes to next subnet, right? Similar way, here we provide the subnet, VPC IP like 10.0.0/16. So this VPC hold around 65,536 IPs, right? So in coming to this subnet, we only provide like 254 IPs only, like because this is 24. Net mask is
But why
24.
wasn't it 10.0.0.0/24?
Yes, we can provide, no problem.
Okay.
We can use 0 or we can use 1, 2, 3, 4, no problem. For example, if we are one more subnet here, like subnet 2, then we need to provide the subnet as another network. So this one would be changed, like, this 0 would change 10.0.1.0 like that.
And the 16 digits are the last parts of the address, right? So it will be
no, 16 is not the last one, but I think VPC
first one.
starting with the 16, right?
So which bits is the mask? The last bits. So that is it is 8 bit, 8 times 8 bit times 8 bit times 8 bit, right? So that's the 16 would be the last 16 bits or first 16 bits.
16 is not the last, actually starting with the 1 to 32.
1 to 32. So it would, that's why you can put that .1 there because that is past the 16th digit.
Now coming to AWS, we need to, in between, we need to choose 16 to 24 or 28 like that. AWS, there's some policies like that. So when we are going to create VPC, we can see they mention in the dashboard, provide a net mask like, starting from 16 or ending with the 26 or 28. Otherwise, the network will huge one, right? Like if you provide 50 here, then again we got a lot of IPs like that.
You wouldn't be allowed to make it like say you wouldn't be allowed to make it 10.1.0.0. You have to make it 10.0 dot, then you can put whatever numbers you want because the first 16 are defined.
Right. Yes. I mean, total 32, right? This is 8, 8, 8, 8. So in this case, our network is divided by like this. This is our network. First 2 is our network and this 2 is our host part. So only these 2 will change, not this network won't change, okay? Because our net mask is 16. In this case, only this one change, the last one. These are our network part and the 0 is the host part. Only host part will change because net mask is 24. Got it?
Yes, I got it now.
Yeah. So now yes, subnet part is done. We provided, we pointed to our corresponding VPC, then provide the IP and mention the available zone and give it a name, production subnet. So the next thing is we created the subnet, right? So we need to create a root table association, right? Because as of now, we have a root table and we have one subnet, but we didn't associate that subnet with the root table. In our case, we already our root table inside the root table, we already pointing like adding target as internet, then pointing to internet gateway. So after we attaching, I mean, associate with this root table, we can say our subnet is public, right? So this is the way we adding root table. Sorry, like root table association. Okay. So coming to this block, resource, then the resource type is root table association. Then we need to give a name, root table association. This is a name that we providing. Okay. And then we need to provide the subnet value. So here using attributes for subnet ID and root table ID. So both attributes we need to provide the corresponding value for our resources. Like coming to subnet, we need to provide a subnet name like C AWS subnet dot my subnet dot ID. So this pointing to this subnet. I mean the root like root table association knows the subnet is associated with this root table association. Then the root table ID information. We already created a root table there. See AWS root table dot root table. So here we need to provide as value AWS root table dot ID. Clear? All of you.
Yeah.
Step created a connection between the root table and the subnet.
Right.
From
But
where
if
you're
you
copy
change the root
pasting.
tables to association with different subnets, then that's allowed because you connect different subnets to a root table you want.
So we need to mention the value as per our requirement. That you mean, right?
No, it's just like you have freedom of connecting the network computers how you want to, right?
Yes.
Okay, thanks.
I hope you all know the manual way of doing these all, right? Because we already done different labs for creating this manual way. So just assume, I mean, just integrate with the manual way. So we can easily find all the solution, like how these integrate with each other like that.
The syntaxes, do you take it from Google or
No.
are these standard?
Standard one. We can customize, for example, coming to AWS, how we creating VPC. This is only way. We can define another way, but this is a standard one, like using attributes and values.
So for example, if I'm doing this manually and I forget one of the, like for example, availability zone, if I miss
So
entering that
we need.
information, it won't, it will error out there itself,
Yes,
right?
we will get error because these are the mandatory things. Like by doing this manual way, these are the manuals. I mean mandatory things, right? I will show you.
If possible, can you show like after the Terraform session at the end of it, maybe a production file? I'm sure it doesn't look anything like this.
Sorry.
No, in production, these files would be huge, right?
Right, yes. We now you know that we are adding different blocks. So as of now, I think we added 7 block. Now the left are like creation of security group, creation of EC2 machine, then similar things there. After that, our code will be huge, like, but it's human driven, right? You can now know that this is pointing to this service, that service, like that, right? All of you.
Yeah.
Yes.
Yes.
So see, coming to subnet creation, okay, see. So whenever we're creating a subnet, click subnet. Here we need to provide the VPC. So we need to provide VPC, then provide, this is VPC area, give it. So provide name. No preference. I think we can leave this. Yeah, we can like IPv4, VPC IPv4, give the IP like 1.0.0.2.0. Here we didn't mention any tag, okay. ADR existing. No preference. Yes, I think we can leave the available zone. It's going to default one, any of the default one. If we leave, if we have any specific one, then we need to choose as per the requirement. For example, the data center, these all as per the project actually. So the requirement is just deploy your application to the specific area or like that.
I think in real time it's mandatory, I guess.
Right. We will get the requirement actually.
Okay.
See, now it's going to available its own ID. Yeah, see, this is one I created. So it's pointing to the first one, like US East 19. We didn't mention anything, but it's by default, it's going to US East 19. Got it. Then the next thing is we need to create internet, security group. So coming to security group, we need to mention the ports. I mean, why we creating security group? To enabling port or closing port, right? And after that, we different way we can create security groups. For example, when we creating a EC2 machine, at the time we can create new security group or choose existing one, or before we can create a security group and add the port, like what are the port that we need. Then we can attach, like when creating EC2 machine, we can attach the security group. That's why when creating EC2 in the console, we can see two options: create new security group or choose existing one. So in this case, we are going to create a security group. So coming to security group, this is a security group block, okay. So coming to security group resource, we need to provide the security group type, okay. That is AWS security group. Then we need to provide the name for the resource, that is instance security group SG. Then give a name. This is like when we creating security group, we can see there is a given, we can give the name for like description, okay. Description and name, we can provide both things for the security group. So easily we can find this security group is for web server security group or allowing SSH or SSH traffic. So we can ensure that this security group only for these purposes, like only enabling port 22 and like 8080. That's why we provide a name for security group. Then we need to provide the VPC. Similar way we use attribute and values and pointing to our VPC. Then ingress. What is ingress and egress? We can see one more thing, egress. Ingress is incoming traffic. Egress means outgoing traffic. Like what are the traffic hitting our security group? So nothing, we just opening ports using the ingress. Okay. So how we open port in security group? Use ingress, then curly bracket, then from port and to port. So here we are going to open a port 22, that is for SSH connection. Okay. Then CADR block, this is our target, like who can access this 22 port. So internet, here we provide the internet. So again, we create another port, okay? This is port 80. The next one is 443. I mean, this thing we copied 2 times. If you can leave that. 80, already opened the 80. So again, we created inbound, that is ingress, open ingress, and pointing to port number 443. Again, we open port number 443 and pointing to, here we provide the TCP, okay? I mean protocol. Protocol is equal to TCP. Then pointing to who can access the TCP 400 port? Anyone. I will show you manual, okay? So go to EC2. So now I'm going to create a new security group. Click security group. Now we are going, now we in our Terraform code, we are add the block for creating security group. But as of now, we didn't attach the security group to any specific virtual machine, okay? We will attach when we adding the block for the EC2. So here we can see create security group. See, give it a name, description, choosing the VPC, inbound role, this is ingress, and outbound role, this is egress. Then the tag and create security group. Same thing we added in Terraform. See the name, type, description, choosing the VPC, then inbound rules. We added different ports. I mean, we open different ports. That's why we add ingress, repeat. Yes, I'm out.
So if it helps you, maybe you can keep the window of where you do it manually open, and just all those same words will be in the same, almost same order on the Terraform object, right? Like the block, not object, block. I mean, it may not be in the same order, but it might help you, gives you visually see it if it helps you. You don't have to do it that way. You could do it by Googling something, or you could do it by remembering. Everybody does something differently, right? In their head.
You mean here, right?
Yeah. So you know how you manually create it by clicking stuff, going through that browser, scrolling down the browser. All those same things are defined inside the Terraform file.
Yes.
Each corresponding block. So if you forgot how to do it, you could go to this manual window and.
So yeah, this is the way we doing the manual way. For example, security group name. See.
Yeah. Same information, just a different format.
And given the description. So the group name and description, you can see here, name and the description.
And the inbound and outbound rules are make a block of ingress and egress.
Right. So next we need to specify the VPC. See, VPC option. Okay. So coming to, see, we need to provide the VPC. So the VPC that already we created, the first block for AWS.demo VPC.it. So we here only mention the attribute and value. It makes sense, right? Now we need to add the ingress, that is inbound rule. What are the traffic coming to our security group? So here we are adding the port like TCP. Okay, choosing the TCP. All TCP is fine. Sorry, custom CTP, TCP. Then provide the port number. The first one is, I think, 80. The source, what is the source? 0000. That's the thing we define here. See, port number. Here we need to provide the from port and to port. Okay, that is coming port and hitting port. That is 22. Then the protocol TCP and the CADR block for the target. That is in the line 00000. Now it's coming clarified, right? I'm audible, right?
Yes. Yeah, I think your voice was cutting off just a little bit, but it's back now.
Give me a second. Okay. So, yeah. Any doubt? Anyone have any doubt? Like Shilpa, Mahesh, Tejaswi?
No, I'm fine. I'm fine.
Yeah, I'm good too.
Okay. So the next thing is we can create a
EC2, I guess.
EC2. The last final thing.
We lost your voice, Tawfiq.
Yeah. I didn't say anything. Audible, right?
Yes.
So this is the snippet, I mean block for creating like EC2 machine. So we define under resource. The resource type is AWS instance, the name. Then we need to provide the AMI for our machine, that is our operating system. Then the type, mission type we need to provide, that is T2 micro. Then the key pair, that is new, it will create one new. Then availability zone, we need to mention the availability zone, that is US East 19. Then associate public IP address. When we like this is an attribute and the value is true. If the value is false, then we didn't get a public IP. So for the requirement, this is for web server. So we need to make it true. Only then we will get the public IP. So whenever we creating EC2 machine, we enable the public IP, right? Similar way in Terraform, we add the attribute for the same thing like this. Then we need to provide, I mean, choosing the VPC security group. Okay, this attribute is for VPC security group. So here we mentioned the security group that we already created above. So that is pointing to this EC2 machine. Then the subnet, we already created one subnet like AWS subnet.mysubnet.id. This is a value pointing to the subnet that we already created. Then tag for this machine, that is the name like web server instance. Then this is a small user data. Okay, I mean when starting the machine, first executing this script, actually this is a small size script. This will automatically execute when the machine is turned on. This is nothing, this is installing Apache and enabling Apache, and we use one sudo bash command to echo something. That is this is the things pointing to, I mean this is the content, echoing content, and this pointing to the index.html var www. Got it? And it's ending. So we can see.
So the minus EOF stands for beginning of file, or
Yes.
in the file, right?
Beginning. Yes. You can avoid this user data. So I will show you manually how to add the user data in creating EC2 machine. Okay. So go to EC2 machine, EC2 dashboard, and go to instance. launch instance. So here we will provide the machine details like machine image, then key, machine network, security group, subnet and all things. Then under below advanced details, we can see there is an option for user data. See, user data. So manual way, we can paste the data like the script here, and after launching, it will create. I mean, first it will create, execute the user data, the script, what we are providing here. For example, the script for deploying a web server and deploying some application. So all the things we can paste here. So it will times, we didn't manually log into the machine and install the app services or application. If we have the script, then we can paste there. Similar way, we can add the script in our Terraform.
I have one question. When you have this network of computers in the cloud, how do you know which computer the script will run on?
How to verify, right?
Like generally there is a script running on a particular machine, right? So which machine, is it the machine that you defined the AMI image? That's the machine where the script will run.
Right.
Okay. So that's the user data for that machine, but it's a script.
Right. But here you can see, like, we provide the AMI and we given the name, right? Name, all the things are unique, right?
Right.
So here, coming here, we given the name, like you see, web server instance. That's the tag name for our instance. Then image name, T2 micro, no. This resource for this web server, this EC2 machine. For example, we need to deploy one more machine, like the same scenario. Okay, we need to launch one more machine and running the same script. So we can add one more line here. There is a attribute for machine count. So the machine count is equal to 1 or 2, like that. Then it will create one more machine. How the values looks like. So for example, the machine count is 2, then create 2 machine.
Can you add one more line to add another instance, if possible?
Yes. First, we can run this one. Okay.
Okay,
Then we can add that one. So you can see.
Sure. Yeah.
So one more command there, that is for the getting the output. Okay, after the execution of this, we will get a public. We will get the output of the public API of our instance. So this is a command for getting public API. Okay, of value. We need to mention the server name. That is AWS instance dot web server dot public API. So completion of this script, we will get the public API. Just to copy the public API and we can access the application or access the machine.
Okay. Are we in the Terraform file using VS Code?
Right.
Okay. You already installed Terraform in the
No,
VS Code?
No, not installed.
Okay.
So similar way, I'm adding the user credential. Okay. Yesterday I destroyed the machine. So quickly go to IAM. Now I just created the local machine. Then the user, Terraform user. I think we couldn't see the things again, like the credential, access key. Yes, we need to create. I mean, whenever we're creating the access key, we need to save the access key. Okay. I mean, next time we can't see the things like, so create another one for the same user. We need to ensure that the corresponding region, okay. Otherwise, it will change. I mean, changing all the things like for different regions, different resources are allocated. For example, if we choose US East to 1, okay, here, East to 1, East to 1, because I am using the same US East 1. And in US East 1, our like AMI coming to OS, different IDs. Okay, AMI ID might be changed. Okay, coming to different region. So whenever we are setting that default region is equal to or corresponding, then we need to choose the corresponding details like AMI details or similar like that. Otherwise, that would be changed and our execution will fail. Terraform version. So installation is almost done. Now we need to authenticate with our AWS cloud provider, right? So that we need to add the provider. Okay. So now we are talking with the Terraform that this is my cloud provider, that is AWS. So create a initialization with my AWS account. Okay. Because this machine can access our AWS account. That's why we provide the username and the access ID, private key, all the things. And the users have administrative privilege. Remember that. So we can do whatever we want. Okay. So now we are in the directory EC2. Now I'm going to create a directory like make dir Terraform cd Terraform. Okay. Now creating now provider.tf, right?
Yes.
Tender, and we can search that provider AWS Terraform. See, this is a provider for AWS. And we can try it initialization from this directory to our provider. Okay. To verify everything is fine. Terraform init. See, everything seems good, right? We successfully initiate with the working directory and our AWS account. Now we are going to create our configuration file, right? So our configuration file, in this case, we include all the blocks in a single file. So we can create a main.tf or similar like that.
We can
So,
copy and paste from the VS Code, right?
yes, nano main.tf. So here we can change the AMA, okay? I don't know this AMA is exit or not. Ensure that we are in the same region, use these two one. Otherwise, the AMA ID will change. See the user script for Linux machine. apt-get, yes, that is for Ubuntu machine. So just to copy the Ubuntu machine AMA ID. All are following, right?
Yes.
Yes.
Okay, then yes, is to one, that would be fine. Okay, we can save and exit and run Terraform plan, right? So whenever we enter the plan command, we can see what are the resources that we are going to create. We can review the plan. Expect the CL block on content value. Yes, see. CADR issues with C coming to VPC CADR IP address only 10.0.0.0. Now it's fine. Save again. Run again. Mark index. Main 21. See how we find the errors.
Yes.
See, you'll get the output. So in this plan, there is 7 things to add, like 7 to add. What are the 7 things we can see here? In review section, we can see Terraform will perform following things. And see, all the things are mentioned here. So we can go with the apply command, okay? We can review this section, okay? What are things, all things mentioned here, like a name, attributes, the services, all the things. Yes, Amar, please.
If you click the plus sign next to like tags, IPv6, it opens up and shows you a bunch of the details inside.
Yes, you mean this one, right?
Yes, can you show that?
No. This is just pointing, that's all.
Oh, okay. It's not a drop-down menu.
No.
So if there is anything wrong in the syntax, will it show it at the plan
Yes,
stage itself?
yes. No.
Yes.
Plan stage, we didn't get anything. Yeah, plan stage, we will get 2 errors. See, did you notice that, right?
Yeah, that's what I'm saying.
Oh, this is a error due to maximum VPC reached in our AWS account. So just to go to VPC, delete one VPC there, some limitation there, okay?
I think you should
Yeah, see,
help us debug that errors.
Yes.
You identified it quickly, right?
We can identify easily because the plant shows the error and where the exact error, like just to go to the line, okay? That's why I'm checking the Visual Studio Code line 21 have some error. So coming to 21, we can see there is some values are there like 0 dot something like that. So I remove the things. Then first one is IP CADR is not correct. See, here I didn't change. This is the IP we included in our first plan stage. So I just do nothing, just add the IP. That's all. I mean full IP for our VPC. Now we get one error. See, this is error creating VPC. It's reached maximum. The maximum number of VPC has reached. So what we'll do, we come here and delete one VPC. Click delete. Now only 4. 5 is the limit, I mean the maximum in AWS account. So again, go back and try it again, apply. Yes. See, it's creating VPC just to check that thing.
Tausif,
Yes.
if I'm creating multiple VPC, if I'm not deleting that one, is this going to chargeable?
No. Not chargeable.
Okay.
See, it's creating all the like inner gateway VPC. What are the blocks that we are adding in the Terraform file? It's creating. See now see it's completed and we get the IP. Just check it out. Copy. I don't know I can access or not.
Not copied, I guess.
This is a public IQ. I mean, we have one last like command for showing the IP of the EC2 machine. So it will display the IP. So just paste and 80. See, Apache is running, but it will take some times to display the content. Just refresh. See, welcome to my world. So this is our application. Got it. So how simply we can configure all the things, like only some first, I mean, initial stage, we need to like spend some time to create the configuration file. Then next time we can customize as per the requirement and just deploy these things. So it will create within seconds, it will create the entire thing like full infrastructure. So just to go back to VPC, here we can see what are the things we created using the Terraform file. So our VPC, VPC here, production VPC, then the signing to subnet. See production subnet. This is a subnet we created. Then the route table, production route table, internet gateway, internet gateway. I think this is the internet gateway. Yeah, we didn't mention anything, any tag for the internet gateway. That's why there is nothing here. So this is one pointing to production VPC. So yes, we finally deploy the.
We mentioned actually GW like that.
No, that's a like type name. That is not the tag name. If you add the tag, it will show. Yeah.
Okay.
See, this is a web server. That's the mission that we launch. This IP we will display after execution 3.29, right? Go on. Yeah. So this is a way we deploy infrastructure using. Now it's we created a entire data center, right? I mean, creation of VPC and the VPC components.
Yes.
So around 10 blocks, I think 9 or 10 blocks are there. So the fun part is we can destroy these things with a single command. Got it?
Terraform
Yes.
destroy.
Yes.
Destroy the earth.
With a single. One more thing I need to add, like when coming to production environment, we need to take a metadata or a full enter detail of our infrastructure. Okay, that is, for example, our configuration file is miss. Okay, like we like it's deleted or anything like that. We need to take a backup for our entire infrastructure. So by default, we will get a backup that is Terraform state file. Okay, the state file is a file that is created automatically when we executing the Terraform apply command. So inside the Terraform state file, we can see our entire infrastructure there. Okay, for example, reviewing the infrastructure, we can just open the test state file and see these are the details in our infrastructure like that. So next time we can edit or like adding the version control, anything we can do with the Terraform state file. And most probably we saved the state file in some S3 bucket or in anywhere.
Security manager.
Yes,
security
yes.
manager.
Yes. We can see the state file here. Go to the directory. Terraform ls. See, these two files we created, right? And these two are created automatically when we running the main.tf. That is terraform.state file and terraform.state file backup. Cat terraform dot state file tf state. See, the entire thing we can see in the state file. I mean, how many VPC are there, how many subnet there, the mission details, mission region, all details we can see in our state file, TF file. So coming to production, we saved these files. Okay, like we need to lock most time we will lock the file because someone some like unauthorized person can destroy our entire infrastructure. Like for example, Terraform destroy, everything is fine. Terraform destroy. See,
I think you have to remove that. Okay.
all removed. I mean, yes. everything is collapsed. Just assume that coming to a production environment, okay, like someone, I mean, intentionally deleting these things will impact the entire business, right? With a single command. So that's why we need to keep, I mean, secure our files, Terraform files, all the things. Most probably we will hard lock, I mean, using some S3 bucket or some table, Dynamo table, using Dynamo table for, I mean, securing these types of files. And only give the authorization for the required people. Yes, Amol. So see, all destroyed.
Like Shilpa predicted, the production file was very long.
Yes. As per the requirement, that would be like, if the requirement is huge, then we need to create as per the requirement, like maybe we need to include more blocks. In this scenario, see, we have around 10 blocks, right? See, like this. And coming to another scenario, we need to integrate some other services, then we need to include that blocks to fulfill the task. For example, in this case, only one subnet. So consider there is 4 subnet, then we need to add again 4 more like blocks. So the code may be huge. So anyone have a doubt?
I don't, but I would like to see more of the debugging of these errors. Maybe create a file which will throw errors and then show us.
Okay, then I will give one task today. Okay, just you all guys just I mean, go through the task. So whenever you face any error, just to ping me. Okay, I will support online. Is that fine?
Shilpa, you shared the secret to becoming a strong developer. Like it's like a defensive program.
See, in real-time
like,
scenario, it's what I have
for
observed from my experience is there would be very less of creating stuff, and it will be mostly managing and making things run smoothly, for which we need to know how to debug things and how to troubleshoot the errors. And mostly, as far as I could notice in my career and from the past experience I had. So that's the key. In real time, it is the files are so huge that just to identify an issue, it becomes a very big challenge.
Right.
Correct. If you're going for the existing project, you'll be having only the handling things. If they want to do some, the new features need to be added to the application, that everything need to be started from the beginning. Like they will tell to create infrastructure, create S3.
Yeah, but that even while creating in production, I don't think we write anything manually, right?
No, initially they will tell you to create in a QA environment, not production.
Yeah. In QA itself.
Yeah.
When it comes to real-time scenarios, do we type like this manually or?
Yes, in Terraform we have to do that. Yes.
And you can refer actually. There is existing files are there.
Yeah, they can copy and paste and modify.
And review and customize. Most probably we customize as per the requirement. So creating a VPC, we know. Yeah. Yes, Mahesh.
Yeah, you can ask your manager any the previous project where I can image that one, or you can take a snapshot of that one.
Then all are good, right?
Yeah. Yes. Have a good night. Good morning.
wind up, right? Yes, good morning,
Sure.
good night, all of you.
Sure. Good night.
So,
Good night.
shall I send one task regarding this Terraform?
Yeah, we would try.
Yes.
Send
Okay,
it.
okay. Yeah.
Right.
Also send the recording, please.
Sure.
Yeah.
Bye-bye.
Thank you. Bye.
Bye.